So this is video notes 1.3, page 2, and our goal is to be able to understand and evaluate random processes underlying statistical experiments. So our second type of sampling method is cluster sampling. And this is where you divide the population into groups or clusters. So you can see here in the picture, there's a population that is divided by different blocks in a neighborhood. Then you'll obtain a simple random sample of the clusters. So maybe out of these 3 blocks, we would want a sample of 1 block. So we would randomly choose between 1 and 3. And then we would use all the members of the cluster or clusters obtained in number 2 as the sample. So if I randomly chose block number 3, then I would actually survey every single person on that block. So here's an example. The City of Hamilton is conducting a survey on the residents' interest in extending the bike trail. Let's say there are 947 blocks of homes, and a sample of 20 blocks are desired to take the survey. Considering the blocks are numbered 1 to 947, which blocks would be included in the survey? So one nice way to figure out 20 different blocks of the 947 to survey, as we said, by simple random sample, is to use a random number generator. Now this is one I just found on the App Store. So you actually set the parameters. The minimum would be block number 1, the max would be block number 947, and we want 20 numbers. We don't want decimals, and we don't want repeats. So then we would generate those numbers. So you can see here, we would just list out these different numbers. So that would be blocks 213, 382, 674, 341, 92, 606, 331, 112, 374, 678, 803, 594, 77, 621, 870, 409, 354, 237, 65, and 290. So in this case, whoever's conducting this survey, the City of Hamilton, would identify each of these blocks, perhaps send them each a mailer with that survey, or email them every single person on block 213 and 382 and 674 and so on, and so that they could collect that information about the bike trail. You'll often find with cluster sampling that's done typically by geographical region. It's something that's done a lot of times based on convenience. Our third method that we're talking about is stratified sampling. So the population in stratified sampling, similar to cluster sampling, is first divided into subgroups called strata. And then the sampling is done from each stratum. So these are the same word. This is the plural. This is the singular. So you can see here, you've got your population being in the large rectangle, and then it's divided into these different strata, and then a sample from each one is taken, versus choosing one of the categories or one of the groups and sampling everyone in it. These two are often confused, so worth taking a minute to study those and commit those to memory. So first, the step-by-step process, and this is with proportional allocation. So there's stratified sampling, and then there's stratified sampling with proportional allocation. So once the population is divided into subgroups, from each stratum you would obtain a simple random sample of a size that is proportional to the size of the strata. So that makes it more fair. Similar to when we did the canned food drive and different classes that had different numbers of students that were contributing to the canned food drive, there was a ratio done in order to decide who would win versus just simply totaling the number of cans, which wouldn't be fair because the number of students that were contributing was different per class. So then use all three members in step 2 as your sample. So for example, cross this out. Let's just say there are 2,000 people in New Miami Township, and use the stratified sampling with proportional allocation to determine a sample of size 10. So let's say that there are 4 neighborhoods, sizes listed. Determine how many residents from each neighborhood should be sampled. So you would think a neighborhood with twice as many people should be able to contribute twice as many votes of this sample of size 10. So the way that we do that, let's call these neighborhoods A, B, C, and D. So for neighborhood A with 400 people, we'd make a ratio to the total population and then multiply by the sample size. Working that out, we get a sample of size 2 from the neighborhood with 400. And then with 600, again, we make that ratio, multiply by the sample size, which gives us 3 votes from the neighborhood with 600. Next is our neighborhood with 800, and you would imagine that would be twice as many as the neighborhood with 400, and it is. And then our smallest neighborhood, if you think about that, that's half the size. So that would give us 1 vote. And oftentimes, if you are doing stratified sampling, proportional allocation is used. So those are our notes from 1.3 on other sampling methods.